Okay, everybody, we're going to talk about inputs to the MicroBit. I'm going to just go through a brief overview of the MicroBit front and back. Then we're going to talk about the 7 different types of input you can receive. So let's first look at the front and the back. And on the front, the input types you have are the A button, the B button, or the combination of the A, B. So you have the push buttons. You have a light sensor, photo light sensor in the middle that'll detect brightness from 0 to 255, 0 being dark, 255 being as bright as it can go. You have the pins on the front. You also have them on the back here. You've got 0, 1, and 2. Then you have a 3 volt. These are not voltages. These are inputs. This is a voltage output, and this is the ground. Never cross the 3 volt and the ground together. It will destroy this MicroBit. Okay, let's look at the back. Ours has this exact setup. It has the compass and accelerometer together. The processor's here. You have a BLE antenna, which is Bluetooth. You have a USB input. You have a reset button, and you have the battery. So what we're going to do is take a look at each one of these inputs one at a time, and we're going to start with the buttons. Okay, guys, like I said, we're going to go with the A and B buttons, which you'll see here we have the MicroBit. We have the A button, we have the B button, and we're going to do something with both. The only thing you need to work with the input on A and B is the MicroBit itself, a way to transfer the program to the USB cable, and a power supply. Now, once the program is transferred here, you can disconnect the computer and it will run with the battery. I'm just going to leave this cable attached for now, so we don't have to keep pulling the battery on and off and on and off. So let's go ahead and plug it in. And when you do, you'll see it lights up. So I'm going to go into the make code. And I've already written a program for the buttons here. I've got it set where on button A, it'll scroll the word scroll across the screen. On button B, it will do the animation 4 times. And on A plus B, it will just show a smiley face. So we're going to transfer this program to the MicroBit. And if you'll watch, there's a little light right there. And first I'm going to pair it, which is connected to the computer. And then I'm going to download the program, and you'll see the light flash. And when it finishes flashing, that program is on the MicroBit. So now if I press A, the word scroll scrolls across the screen. If I press B, the animation occurs 4 times. And if I press both buttons, should get a smiley face for a second. And that is the input of the buttons. Okay, so now we're going to work with the light sensor. The light sensor, not the photoresistor, but the light sensor is built into the front of the MicroBit, into the LED grid. So what we're going to do is detect light, and we're going to write a program using what we did before with the buttons, but we're going to put some conditionals in here. What we want to do is to say if light level, so let's go into logic and get an if else, and say if, let's see, it's not input, yes. So can you pull light level into here? No. What you can do though is check the value of light level by going to logic, and let's get the comparison. If light level greater than, let's say, since it's 255, 0 to 255, we'll go to 128, which is right about the middle. And if it's greater than 128, we're going to scroll the message. Otherwise, we're going to repeat that 4 times. We won't worry about the smiley for now. So as you can see, the light level is 128, but it's not greater than 128, so it's doing the animation. And when we go a little higher, since it's the forever, let's take this out of the loop because it'll loop every time until that gets up there. So when we start this back, 128, it's doing the animation. Above 128, it does scroll. Okay, so now we need to see if that will work on the actual MicroBit. So we are already paired. So we just click download. And you'll see the little lights flashing in the back of that. So now it's saying scroll, which means light is greater than 128. So let's shade it a little bit and see if it'll do the animation. It does. Now let's let light hit it. Give it some light. Then it should go back to the animation because the light is not to 128. When the light hits it, it goes back into scroll. It's back to that. Now, if we keep light constantly on it, it's kind of hard to see. But it'll continue to scroll. So there's not an exact on it. And the thing with a MicroBit is when it does its check, it has to do whatever. So if it's less than 128, it's going to scroll, put the word scroll out before it ever checks again. So you have to let the word finish. And that's why I took the repeat 4 out of this, because right after the X, I can actually have it do what I need it to do right there. So that is the photo sensor that is on board on the LED grid. Okay, so let's look at the compass function on here. The compass is built in. We don't have it hooked up yet. Let me hook this back up here. Well, when I do, it's going to go ahead and load the compass program because I already have it on there. It's just going to start running. But I'll talk about the compass program a little bit before we get into it. On here, you see if it's between 315 and 45, it will show as being north. Anything to the east is east, it just runs off of that. Anything south, and you'll watch as it comes around, it'll become west. Let's just download the program to it again just to pair it. And download. Now, if this is a new MicroBit, instead of coming up with a north, it'll come across the screen and say tilt. To fill the screen, you'll see dots, and you just keep tilting it till you fill that screen with those dots, and that calibrates it. But this one's already calibrated. So you'll see, and I know for sure this is north. It's pointing this way toward my hand, and that's the north part of this room. So if I turn it this way, it's pointing east. If I point it this way, it is pointing west. And if I point it this way, it's pointing south. Now, one word of caution when you're using the compass, be careful with the battery pack because the battery will change its magnetism here somewhat. Let's see here. Yep, see, it changed it to west just by being close to it. Now it's back to south. It picks up the magnetic field of the battery. So now that's saying west. So the battery will change it from time to time. So just be careful with the battery. The way you set the compass, we had to set up a variable called degrees. So under variables, you just set a degrees, and then you set the degrees to compass heading, which is under input. And then you just check to see where it's at. And then it will pop up on there. You could say A, B, C, D. It doesn't matter what you put in there, but it does matter the degrees. So if you made it where it was only between, if you want to do northwest, southwest, northeast, southeast, which would be in between each one of those, you could do that as well. It just picks up the degrees. Okay, next thing we're going to look at is rock, paper, scissors, which is actually the accelerometer, just to show you how that works. Let's see, I've already got that program on here somewhere. I think. that it? Let's see. Open. Yeah, that's it. So the first thing you do is set up a variable named hand, because your hand makes a rock, a paper, or scissors. So this is a rock. I mean, this is paper. This is a rock. This is scissors. So you tell it, pick a random number between 1 and 3. And if it's a 3, show the paper. If it's a 2, show the rock. Otherwise, show the scissors. So, and it's set to all this to happen on shake. The accelerometer is what picks up shake. So let's click shake. There's the scissors. There's the paper. Where's the rock? There it is. There's the rock. So right now we have the compass running on our MicroBit. Let's see if we're connected. So let's download rock, paper, scissors to it. And let's see if we can zoom in a little. Not out in. There we go. So now that it's on here, let's shake it. And we got scissors. Let's turn it back around where it's the right direction for you. And by doing that, we got rock, then we got paper, we got rock, scissors, paper, scissors, scissors, paper, paper, scissors, rock. So that just shows you how it can pick up motion, like shaking it. It can pick up speeds, and we're not going to drop it to show what free fall looks like, but it can do that depending on what you're working with this. But that's how the accelerometer works. Okay, now we need to talk a little bit about the difference between digital versus analog and how these inputs are seen. We know that digital is represented by 1s and 0s. So digital can only be on or off, where analog can be a range. Like on the light sensor, we did 0 to 255. That is an analog input, where a digital input would say it's either there or not. It's 1 or 0. It's on or off. It's true or false. And we've talked about this quite a bit. But we're going to look at the other 3 external sensors now. And the first one we're going to look at is the pressure sensor here. So let's move the photoreceptor out of the way and move the flex sensor out of the way. And we're going to use a couple of new things. We're going to use some alligator clips, and we're going to use some leads. The way these are made, they have to have wires to go into them. So I'm going to put the lead wires in the end. And on the pressure sensor, it doesn't matter the polarity you use. You can put either on each one. Now, when you hook this up, you want to put one to the, let's see here. Make sure I'm doing this right. Yeah, okay, so let's put red and yellow on. Let's not worry about black because we're not grounding anything yet. We're going to put red on pin 0. And we're going to put yellow, or actually let's go with red from the 3 volt. That's positive wire, so let's go 3 volts with red. And we're going to go from pin 0. So let's put that on pin 0. And let's see, let's move these down where we can see what we're doing. The pressure sensor, let's put yellow to yellow. And red to the other one, to the green. I just didn't have a red and yellow that were together. This one alligator clip is not very fun to play with. Okay, so what we're going to do, in fact, let's fold these down. It's still running rock, paper, scissors right now. We're going to put a new program on here, very simple program that just shows us the pressure applied to this sensor. Here we go. We don't want those to touch. That'd mess up our reading. So we're going to do it forever. Let's make a variable and call it value. Okay, so let's set value to 0. And then let's show number. And go back to variables, value. Now there's no real way to test this over here. So what we're going to do is go ahead and download it. And that should be over there, and you'll see a value. And it's showing 0 right now. Oh, I'm sorry, I didn't mean to set value to 0 because that's what it is. Let's see. Let's go into pins down here under advanced. And we're going to do an analog read pin 0. There we go. And then let's download it. So now you should see a pressure reading of some sort. Let's see. With no pressure to it, it reads 331, 325, somewhere in the 320, 330 range. Let's move the sensor up here where we can see it and still see the microbit. So when I apply light pressure, I applied too much. Light pressure, let's say it's 909. Okay, when I put heavy pressure, should be around 1021, 1024, somewhere in that range, 1020. Okay. And the way we can use this pressure sensor is if there's something on here. So when there's nothing on there, it registers in the 320s, 330s. Let's put a roll of quarters on it and see what it comes up with. It comes up with 973. 977. Okay, so it's somewhere in the 970, 980 range. So what we can do is conditionally test this to change something. So instead of showing the value, let's put some logic in here and say if, let's take the show number out because we don't care about the number right now. Well, yeah, let's leave it in there. Show number. If, let's go to logic. Value. If value is greater than, or no, let's say less than 550. Let's just show a frowny face. Show icon. I guess I don't. Let's show a skull. As long as it's, and let's make that greater than, no, less than, that's right. And then let's go, else show a smiley face. So when we download it, you've got pressure on it right now, so it should just show a number. And smiley face. 932. And a smiley face. Now let's take the weight off of it. 336. Skull. So you see how that could be used maybe to detect if something has been taken or if somebody puts it back. We now have our smiley face back again. So the world is good. And if you took the show number out of it over here, let's just take that out. And then all it did, let's download. And this would be a more instant thing. You've just got a smiley face till it's moved. You got a skull, got a smiley face back. You got a skull. And we're going to get to outputs in a moment, how to set off alarms and lights and things like that based on some of these inputs. But right there, it just shows you something's been moved. Oh, didn't get it on the sensor. Good. There it is. Back to smiling. All right. So that is the pressure sensor. Okay, now let's look at the same program we're using, the pressure sensor. Let's see where's my pressure sensors off screen here. It still is. Here's my pressure sensor. There's my roll quarters. There's my, wait, oh, it's not on there. It's good. Let's see. Okay, showing in the 900s again. You take it off and it's showing in the 300s. So let's replace that sensor with a photo cell, photoresistor. So let's see. Let me get these undone. All right, so it's showing ambient passage of 256. Yeah, that's okay. So now let's hook the red to one side of this photo receptor. Pardon me, this one clip is so slick, it's hard to get a hold of anything with. Okay, there is that one. Let's spread it apart a little bit and put the yellow on the other side. Now you see light is picking up pretty high, 932, 930. Okay, let's cover the sensor up and see what it reads. So even with light taken away from it, it's still reading 621. Let's see if I can cover it a little better. Man, that's just getting some high readings. Okay, anyway, 7 to 900, like that. Now let's add some light. So I have white light here. And shine it on there. And you get 1021 or 1020. So that's the analog reading off that. The range is somewhere between darkness on it was, I mean, not darkness, but covering it up with my finger. Okay, 392. Let's see if we can maintain. It goes back to 6 something. So there's not a lot of stability in that. So we may want to look at this as being an actual digital input. So if we come back over here and we say, let's take analog read out, go back into pins, pull out digital read pin 0. Okay, let's download it to the bit. And you see a 0. So it's determining that it's not very bright, or if light hits it, we got a 1. Back to 0, we got a 1. It'll stay 1 as long as you've got that light on. You turn the light off, back to 0. So this again might be something that instead of show the value, let's put an if in there, logic. No, not that one. Nope. If else. So let's go to logic again. And say, if the value equals 0, basic show string dark. Else, not show number, show string or light. Okay, so let's download it to it. And now it will display that it's dark. Keep showing dark. Now let's put the light to it. And now it says light. As long as it's picking up light, so you will either know it is light or dark. You have to measure your thresholds. Let's see here. If I turn the overhead light on in here, give me just a second. Let's see if it shows light. No, it's still showing dark, so it's got to have a pretty intense light on it to show, like this one. Now it's showing light. Let me kill this. So that is the photocell receptor. And my chair's rolling around. Okay, we're going to look at the last sensor now. It is the flex sensor. And right now we pulled down the same code we had before. The set value to analog read pin 0 and display value. Well, when there's no pressure on it right now, it's reading 975, 977, somewhere in that range. So when we put pressure this direction on it, it should increase. It'll show 978. Let's see. 980. 980. Okay, there's 980. Let's let back off of it. And it says 976. So if we go the other way with it, it should now drop down into the 940s, 950s. There's 946. 947. Okay, so let's leave it sitting here with 976. That's fine. Let's pull in an if block And we're going to say if the value is greater than 965, let's go with 965. And if it's less than, or if it's less than 955, we're going to do one thing if it's greater than 965, one thing if it's less than 955, and otherwise it'll be something else. So let's see, what do we want to do on those? Let's see, display an emoji. Let's do a happy emoji. Let's do a smiley face. Let's see, if it's between 955 and 965, let's do an X. Oh, if it's between, but if it's less than 955, we want the frown, or we'll put the skull. I like the skull. Where is the skull? There he is. Okay, so let's download this to our MicroBit. And right now it will show us a happy face. 976, still a happy face. So let's bend it back this way. And let's get it to, why is it showing 0? Oh, I'm looking at the wrong thing. We're at 954. So we've got a skull. If we let off of it a little bit, we got an X. 955 X. Go it there, and we should have a smiley face. Oh, I'm sorry, not there. There. A smiley face. Move it a little bit for an X. Move it a lot. And still, there it is. Cap flow 955. Back to a smile. 960 is an X. So it just detects this thing being flexed. Let's see, 963 should be an X. 944 is a skull. So it does detect the differences in the flex of this sensor. So that concludes our input sensor demonstration. We'll move on to outputs. I want to put this out there as a video and put some questions to it. Let y'all answer it. Have a great day, and I'll talk to you later. Bye.